我等它烂了嘛。Okay, hi everyone. We continue our lesson. Okay, our lesson, that's tutorial 3.3. Okay, hopefully you are finished all the question. Okay, now I want to discuss the question and I want to give you the procedure. You see how to do the calculation? Then after that I will show you the actual answer. Okay, at the end so I just show you the formula first. Okay, later at the end I will show you the answer. So when I show you the calculation, so you do first. For the student you are not yet do. Okay, come and see the first one. There's a 3.3 man-made satellite. Okay, the first one they call you to calculate the energy to send. Okay, 50 kilogram aircraft without the man to space from the surface of the earth. So that means you don't need to plus about the height because there's still surface. This one is the earth. Okay, so your aircraft is here, surface. Okay, now the small m, we know the small m of the space, the aircraft. Then after that the mass of the earth we also know. Then g, gravitational constant. Then this one's the radius of the earth. Okay, so from here we need to count about energy. Energy is 3.3. Remember, for the escape velocity, 3.3 is one of the formula related with the energy. Okay, so we go and see the energy, how to create the formula. Okay, before that the energy formula is a force multiply the displacement. This one is before that we learn. Okay, now the force for the gravitational force we take as a G, capital M, small m, over the R square, multiply with the, okay, now the D we count about the radius, because they move to the surface. So this one still energy. Okay, R and R we can cut it. Finally, what's the formula for the energy? So the formula become G, capital M and small m over R. So this one we call it gravitational potential energy, just using for gravitational. Okay, so we need to apply all the thing in, then you find the answer, what is the energy. Final energy, the unit should be joule. Okay, remember it's joule. So this one is a formula, you apply all the thing. I show you the final answer here is 3.14 times 10 power of 9 joule. So this one is the final answer. Okay, now we go to the second one. Okay, what is the minimum speed? Minimum speed, that means later you need to find about the speed needed by the spacecraft to escape from the planet. Okay, where the mass of the planet is half the mass of the earth but same size. Okay, same size, but they say the mass for the new planet now, that one is a escape from the planet, the mass is a half from the earth. So later we know here the mass of the earth is this one. So now your chain become half. Okay, make it become half. After that you need to find out is the velocity. So remember the velocity. So this one is a spacecraft. Okay, spacecraft means you need to find out is the escape velocity. There's an escape velocity, there's a spacecraft. Okay, so from here we're using the escape velocity. So remember formula for escape velocity, there's a V equal square root, okay, 2 gm, then over the R. Okay, this one is escape velocity. Okay, so from here they got the word for escape. Okay, now the M you need to change, because this one M is the mass of the earth. Now the new planet, they say there's a half the mass of the earth. So from here, half, actually we can write square root 2g. Okay, now your mass is a half, is it? So you from here need to divide by 2 lah. Okay, finally the 2, actually we can cut it. So the final answer I show you, the answer should be 7.93 times 10 power of 3. Okay, there's a ms -1. Okay, the detailed calculation later I will show you. So from here I just show you the formula what you need to use first. Okay, then we go to question number 3. Determine the mass of the earth. Okay, mass of the earth. They want to find the mass of the earth, means a capital M. From the period, okay, time taken is given. Okay, and the radius. So we take this one is a T1. This one is a R1. Okay, of the moon orbit around above the earth. Assume the moon orbit the center of the earth. So you assume the moon there's a orbit the center of the earth lah. So from here we got time taken, we also got radius. Okay, but the question they want to find about the mass. Okay, we don't have any second formula for the time, so we cannot using the equation T1 over T2. That one no need to use. Okay, we're using the normal mass formula, mass of the earth. Okay, there should be 4 pi square r cube, then over g t square. So this one is a formula to find the mass of the sun and mass of the earth. So we can apply all the things. G we know already. Time taken. Okay, you help me to change this. T convert becomes second. Okay, 27.3 days convert to second. Okay, 1 days they got 24 hours. 1 hour they got 3,600 seconds. So you help me to convert. Then you go to square. Then this one, can you see this one is a kilo? This one is a kilometer. So later you need to convert. This one become kilometer. Okay. Then after that, we continue lah. The rest is a constant number. So final answer, we get it. There is a 5.93 times 10 power of 24. Okay, kg. Okay, we can try now. I press the calculator a while, you see correct or not. So the radius is 3.82 times 10 power of 5 times 10 power of 3. Okay, after that we need to multiply about the 4 pi square. 4 multiply the 4, then multiply the pi square, divide by the g, divide by the t square. So later we check this one answer, because I forget to be square for the kilo. Okay, you see here. This one we got 1 of the kilo. So you help me to check. Later we see the answer. Because we find it the answer not exactly this one answer. Okay, we check later. So we just hold it. So I want you to do using this calculation. The formula should be correct. Okay, now we find the time first. We one by one step to do it. Okay, time they got 1 day 24 hours. Now we got 27.3. So 27.3 days times 24 times 3,600. So your time taken should be, okay, we drop down the t first. Okay, the T, you get it. Okay, I change the color. T now is 2.36 times 10 power of 6. Okay, second. So this one is what I do it. Okay, so now we go to see the calculation. So we can press the calculator now lah. Okay, R, you see there's a 3.82 times 10 power of 5. Okay, still times 10 power of 3. Okay, so this one is R. You need to cube. So you need to cube. Okay, straightforward, you multiply with the 4. Then you multiply with the pi square. Okay, then you divide. Divide first one, we go to divide by the G first. Then you divide again. For your time taken, there's a 2.36 times 10 power of 6. Okay, suppose the answer here is 1.39. Okay, I get it, it's 1.39. Later we want to redo it. Is it correct or not? 1.397. 1.397 times 10 power of 31 kg. So this one is the mass. So later we recheck again, is it correct or not, because this one I miss about the calculation for the R need to kilo. Okay, so now we continue with the next one. There's a number 4. Okay, number 4, the Jupiter Garridian, there's a moons, LO. Okay, LO. Another one we call Europe, mix of the complete revolution around it over the period. There's a T1 and T2. So that means now they show you 2 of the orbital periods. Okay, knowing that the revolve around the Jupiter at the distance, there's a, okay, this one is the distance. Okay, determine the linear speed of the Europe's motion in the orbits. So from here they want to find is the speed, velocity. So from here you want to find the velocity. What formula we can using for velocity? V equal 2 pi r over t. Okay, we know the t, Europe, for the Europe motion, there's a t. We know there should be this one, T2. But the problem, we do know the r. What's the r for the Europes? But we know the around Jupiter, the distance, this one. Okay, but we do know the Europe is how many. So from here, we need to do the calculation. Remember this one, T1 cube over T2 cube square. Not cube, square first. The back. Okay, we write again. T1 square over T2 square equal R1 cube over R2 cube. Okay, we take the one should be the Jupiter, another one should be the Europe. Okay, now we find it, the R2 is how many first? Okay, you find the R2 we take the Europe. Okay, R2 we find it, there's a 6.71 times 10 power of 8 meter. Okay, so from here I need to find is the velocity. So from here I need to take this one, move this one in. Okay, one more thing, your time must be changed, because 3.55 days you need to convert become the second. Okay, so from here we convert to the second. 3.55 days, 3.55 days. Okay, 24. Okay, we find it, there's 3.02. Okay, so 7 only, times 10 power of 4, 345 power of 5 second. Okay, so this one is what we need to do. there's a time taken. Okay, after that, the following, we need to convert the time go in the whole formula. Then you find out the V should be 1.38 times 10 power of 4 ms negative 1. So this one is the answer when you find the velocity. Okay, we try to check is it correct or not. Time taken 24 times. Okay, so this one is the time taken. Okay, time taken is correct. Then 2 pi multiplied with the R. The R we find is 6.71 times 10 power of 8. Okay, then you divide the time taken. Okay, the answer should be correct. There's a 1.38 times 10 power of 4. Okay, so this one is a calculation for number 4. Okay, then we go number 5. Okay, a 20 kilogram for the satellite has circular the orbit with the period 2.4 hours. This one H stand for hours. So we know the time now is 2.4 hour. Okay, now the radius around a planet of unknown mass. Okay, this planet we don't know what is the mass. Okay, then we know the radius. This one is a R. Okay, if the magnitude of the gravitational acceleration of the surface of the planet, that's a 8. Okay, what is the radius of the planet? Okay, now surface, there's a exactly there's a 8, so we need to see which one calculation formula we need to use it. Okay, G is a 8, then the R is 8 times 10 power of 6, time taken we get it. Okay, so from here what we need to find? We need to find is the magnitude, gravitational acceleration. Okay, radius, what is the radius of the planet? Okay, radius of the planet. Okay, before that radius, what? Radius around a planet of the unknown mass. So the questions to be asked about the mass is it? What is the radius of the planet? I think this question got a little bit problem. They're not related with the if the magnitude. Okay, so you have me to change. So they give you the radius. What is the mass? Okay, what is the mass? Is it the mass? Okay, check first. A radius 8 around a planet of unknown mass. Okay, so we need to check there is a mass of the planet, then the radius of the planet. Radius is a 8 around the planet of the unknown mass. Okay, so this one is a planet. Here we got satellite, orbit the period 24 hours, and the radius around a planet okay, this one is okay, the planet radius. Okay, then around the planet unknown mass, then after that the magnitude gravitational acceleration on the surface, that means the G should be 8. Okay, now the question they ask, what is the radius of the planet? That means this part. They ask the radius of the planet. Just now the 8, the one is the radius around the planet to the unknown mass planet. Okay, so this one is a satellite to the planet, the radius. Now they want to find what is the planet radius. Okay, so we need to do the calculation. They must relate it with the R. Okay, R for the planet. Okay, the problem is we do know the mass of the planet. So we need to find out what is the mass of the planet first. Okay, let's retry. First one, let's see the formula. Mass for the planet, that is 4 pi square r cube. Okay, the r is normal r, small r we're using. Okay, the small r cube, then over gt. Okay, so from here, mass we need to find out is how many first. Okay, this one r. Okay, this one r should be, you take that is g okay, wait a while. A radius 8 around a planet of unknown mass. So the radius, there's a 8, so we need to do the calculation. The mass. Okay, so I understand already. The mass should be like this. Okay, sorry, so I need to explain again this question because got some mistake. Okay, redraw again. You see what they want first, because so many radius we don't know which one is which one. Okay, this one is a planet. The mass we don't know. After that we got one of the satellite. There's a 20 kilograms. Has circular orbits. Circular orbits. Okay, with the period is 2.4 hours. The radius of 8 around a planet of unknown mass. Okay, so we take this one. Should be like this lah, because you want to find is a radius of the mass. So if the question give you 8, means there's an overall. If not, we cannot find. If they give you half, we cannot find. So this one is an overall mass. If you want to find this part is how many, so you need to know the h is how many, then plus together. So that means r plus h, actually there's a 8 times 10 power of 6. Okay, so this one is the total distance. But the problem now, we do know the h is how many. So when we do know the h how many, that means we cannot find what is the r. Okay, so from now we need to find out the formula to find out what is the r or what is the h. Either one lah. Either one you can find, then you can get the radius of the planet. So from here the question, they want capital R. Okay, one more info is, okay, the gravity here, there's a 8.0. Okay, so this one is the information we get it from the question. Okay, so now we need to do the calculation. So now we understand already the question they want is a capital R. That means the radius of the planet is how many. So from here, radius of the planet is how many? Normally we using the formula G equal G capital M, then you R square, is it? This one R is this one R. Okay, that means just surface only. Then we know this one is a 8. So problem is, we do know the M. M is how many? We don't know. That's a planet mass. Okay, so from here I need to find what is the M. So I need to using the formula mass of the planet. Okay, there is a 4 pi square r cube over gt square. Okay, T you need to convert. T is a 2.4 hours, is it? 2.4 hours multiply 3,600. Okay, you find the mass of the planet first. Okay, we find it, the mass is a 4.059 times 10 power of 24 kilograms. Okay, this one's a planet mass. Okay, after I find the mass, that means I need to find out what is the radius of this planet. So I need to apply is a G equal capital G. Okay, now you put in the mass, 4.059 times 10 power of 24. Okay, R square. So this one is a 8, is it? So you need to find out finally the answer R is how many. That means you need to square root. So from here I get it, the answer is 5.82 times 10 power of 6 meter. So better you go and check, is the answer correct or not. Okay, so this one question you need to separate by 2 parts. Understand first, then separate, then you find out which one formula we can use it to find the radius of the planet. So that means now I find it the R is this answer. So that means I don't need to find about the H lah. I also don't need to minus. Because we know straightforward we get the R. Unless the question say they want to find the H. So you need to take this one answer. 8 multiply 6. Then minus the R. Then you know what's the H. Okay, so we go to question number 6. Okay, let me clear first. Okay, question number 6. The Venus and the Mars. The planet is our solar system. Okay, the acceleration due to gravity and also the escape velocity in both planets are different. Okay, FFERENT. Okay, give the G. Okay, table 1 show the mass and radius of the both planets. Okay, now we're going to see the table 1. Okay, table 1 they show you the both of the mass and also the radius. Okay, now we're going to see first one, calculate the acceleration due to gravity. So you need to calculate the acceleration due to gravity. Okay, refer the question. Is it surface? Okay, same gravity, escape velocity. Okay, now they say about the acceleration due to gravity, Venus and also the mass. So we straightforward apply the formula because this one not a satellite. Satellite, that means you need to relate it with the H. Now not satellite, we straightforward calculate the gravity of the Venus. Okay, first one we count the gravity for the Venus. Okay, formula is a G, capital M. Then radius of the Venus, there's R square. So we get it the answer 8.878 times 10 power of, okay, no times 10, straightforward, there's the answer, ms negative 2. Okay, next one should be the gravity for the Mars. Also same formula, just you using the m and also the radius should be different. So R square. So the answer you get it is 3.71 ms negative 2. You can see there's a big difference. For the Mars, the gravity is so small. Okay, this one is for the Venus, 8.87, but still smaller compared to the Earth. Earth is 9.81. Okay, now we go to the escape velocity. Escape velocity, we just got one formula, V equals square root 2 gm, then over the R. Okay, so the first one we get it. For the Venus, the answer is 1.04 times 10 power of 4 ms negative 1. Okay, for the Mars, there should be 5.02 times 10 power of 3 ms negative 1. Okay, so this one is what we can see for the gravity and also escape velocity for the Venus and also the Mars. So can you see for the answer, always is the Venus is the biggest one. Okay, Venus should be the biggest. You check the gravity 8.8. Okay, you check the escape velocity for the Venus, power of 4. So from here, important is what should be the changes. Important is the mass. Mass is the first affected the gravity and also the velocity. Okay, the radius both also power of 6. So important is the mass. When the mass bigger, gravity bigger, and your escape velocity also increase. So from here, they call you to compare the value of the acceleration due to gravity and escape velocity for the both planet. So we find it, the value for both. Okay, for the acceleration due to gravity and also the escape velocity at Venus bigger than Mars. Okay, Venus is bigger than the Mars. Then we need to explain why we get the answer like this. Important is the mass. So we just say the Mars has smaller mass. Okay, the Mars has the smaller mass if they compare with the Venus. Okay, then I need to show you is the calculation 1 to the 6. Okay, let me open it. Okay, number 1. Okay, this one is the number 1. Just now I say I want to show you all the calculation. So we check. Number 1, there's 3.14 times 10 power of 9 joule. Okay, then we go to the second one. Okay, this one, second one, I get it, there's 7.93. Okay, you check because 2 and 2 we can cut, is it? 2 and 2. Then we can cut it. Then you press your calculator, is it correct or not? Okay, then we check this number 3. Then just now I call you to check number 3, is it? Now we go and see number 3. Is it got problem or not? Okay, number 3. I think that's okay lah for number 3. You see, I put 4 pi square already. Okay, after that 3.82 power of 5 and power of 3 again. Then I go to cube. Okay, after that I divide. Okay, 27.3 days and times 24 and times the 3600. After that need to square. So we press again the calculator, check is it correct or not. 3.3 times 24 times 3600 square. Oh yeah, just now I forget go to square about the time. So that means remember the time need to square it. Okay, so I make it bigger. So you must see here. Okay, this one must go to square. Check. Okay, remember the time must go to square. Just now forget this step. When you just forget this step, that means all the thing must be wrong. So okay, so you be careful for this step into square. Then this one need to convert become second. Okay, then one more is a kilo. Okay, the question sometimes they put the kilo, we cannot see. Okay, if this one no problem, then we continue with the number 4. Okay, number 4, using the formula for T, the orbital period, that's directly proportional with the radius cube. Okay, final answer, there's a 1.4, or you say 1.38 times 10 power of 4. So this one question, you need to find the R first. You find the R first. After that, using the R, then find out what is the speed, linear speed. Okay, this one question never say about the escape. They just say the speed. So sometimes the question you must read very careful. They got mention about the spacecraft or they say about the escape. Then you need to using the escape velocity. Okay, now we go to number 5. Okay, number 5, that means you need to find out is the, just now I told you, is it the mass of the planet, we do know how many. Then the radius, this one radius is the overall radius. So I repeat again. So this one is the planet. Okay, planet. The mass is how many, we do know. Then after that they say they got one of the satellite. They got orbit. Okay, around the planet. Okay, then they told you this one is 20 kilograms. Okay, after that they circle the orbit periods. They give you the time taken. They circle one orbit is 2.4 hours. Then after the radius, okay, this one is a keyword. The radius means this part. Radius of around a planet of unknown mass. The radius they around the planet, that's a 8 times 10 power of 6. Okay, after that they told you the gravitational acceleration on the surface of the planet. That means this part, the gravity is 8. Now the question finally they want to find out is, okay, let's change about this one. Radius of this planet is how many? So normally you want to find this one radius is how many. We take the 8 times 10 power of 6 minus the h, then we know the r. Is it? This one is a h. This one is a h. This one no. Okay. So from here we do know the h. So what we need to do? We need to find the h either one, or you do one, you straightforward find the r also can. So how to find the r? You need to find the mass lah, the mass of the planet first. After you find the mass of the planet, that means you can find out this one. Found already? Then you're using this formula, okay, to measure the calculation. What is the r? Okay, so you need to square root, final answer. So the r, where's my r? Okay, r is hilang already. So the r answer is 82 times 10 power of 6 meter. Okay, so this one is the answer. You need to square root lah after you do the calculation. Okay, then we go to the question number 6. Okay, let's see the question number 6. Okay, question number 6, they call you to calculate the acceleration due to gravity for the Venus and Mars. So just now I showed already, we're using the formula, this one. Because this one not satellite, so we straightforward using the radius. So after I do the calculation, the first one I get it, 8.87 for the Venus, then this one is a Mars. So we also say this one should be the bigger lah. Okay, for the Venus, should be the bigger. Okay, the next one we calculate about the escape velocity for the both planet. It's a B. Okay, this part. Okay, we're using the escape velocity, the formula, filing the Venus and also Mars. Okay, first one we get it 1.04 power of 4 only. Okay, another one is a Mars, that's a power of 3. So from here we find it, the Venus should be the bigger. Okay, bigger due to the mass lah. Then we need to see is just now I show you the explanation, is it? So you write the explanation already, is it? So we just say about the comparison. So comparison, just like I show you the answer, so there should no problem lah. The value of the acceleration due to gravity and the escape velocity at the Venus equal at mass. Reason, because the mass has smaller mass. Okay, because of the mass. Now we go to question 7. Okay, let's see the question 7. Okay, question 7, there's a satellite orbiting the Earth at the height. Okay, satellite again. So I draw. Okay, now this one is the Earth. Okay, satellite again. Okay, orbiting. The height is 250 from the surface. So this one we need to do the calculation later. 250 kilometer from the surface of the Earth. The mass of the satellite 100 kilograms. Okay, and the radius of the Earth. So this one is a radius. Okay, R is provided. So now the question asks, what is the radius of the satellite? So radius of the satellite means you need to plus two things, capital R and also this part, is it? So this one we call total radius of the satellite. Okay, so from here we do the calculation. Just the small r plus the h. So that's the answer. So we write here, there's a 6.4 times 10 power of 3. Remember this one got 1 more kilo. Then the plus about 250 times 10 power of 3 also. So the final answer I get it, there's a 6.65 times 10 power of 6 meter. Okay, so this one is what I want to show you. Okay, you can change become kilometer also can. Straightforward, you take 6.4 okay, times 10 power of 3 plus 250. So your answer in kilometer. Okay, I write properly. Okay, if you're using the kilometer, still okay. There's a 6.4 times 10 power of 3 plus 250. Okay, so your answer is a 66650. Then after that there's a kilometer. Okay, 6650, there's a kilometer times 10 power of 3. Then it should be okay. So this one also is the answer. Either you write 6.65 times 10 power of 6 meter, also can. That should be the answer. Okay, then we go to the B, 7B. Okay, 7B. What is the gravity of the satellite if the gravity of the Earth is a 10? Okay, 10. They ask about satellite. Now the satellite is R plus H. Remember, there's a far away 250 kilometer from the Earth. So from here they ask you what is the new gravity for the satellite. Okay, if like this, we need to using the formula. Remember the chapter 3.1 we learned when you far away. Okay, we put the line. So the formula is R, capital R plus H, total go to square, multiply with the G. Okay, G is a gravity. Now the gravity they take there's a 10. So I find it, the answer here is 9.26 ms, -2. This one is the satellite gravity Why they cannot get about 9.8? Because there's a far away a little bit. Almost the same lah. They just almost the same with the Earth. 10 ms negative 2, or you say 10 Newton per kilogram. Almost the same. So from here, we write the answer, there's a 9.26. Then you need to give the reason why like this. So the reason is they cannot exactly become the 10. Reason because they're far away a little bit from the Earth. Okay, so we get the answer, this 9.26. So from here, I want to show you the answer, what the explanation for this question. From here, we just assume they almost same like the 10. Okay, let's see the explanation first. Okay, 7, this one is a just now answer, R plus H. B, okay, you see the answer here. Calculation for you, this one is a normal surface. When the planet on the surface, or the satellite on the surface, we're using this formula. So when there's a more than the surface, then the R more than capital R, because you plus the H. So from here we take the G prime over the G, so I get it this formula. Okay, so from the question we know G is a 10, so everything I put in. So when everything I put in, I get it, my answer is 9.26. So from here we assume the 9.26, they almost same like the 10 okay, because there's a closer. Okay, if not, we take there's a 9.81, is it? There's a closer. So from here the explanation is distance of 250 km from the surface of the Earth is not too far from that's affected from the Earth gravity. So you give the reason why you get this one answer. Okay, that's a not too far lah, but still got a little bit height. So from here, so we just answer, the answer is 9.26. Then you put almost equal to the 10. So the distance of 250 km from the surface of the Earth is not too far, okay, from affected of the Earth gravity. Okay, so this one is the answer for B. Okay, then we need to see is a number for C. Okay, number for C. Okay, C. What is the force acting on the satellite while orbiting the Earth in the certain orbit, and what is the value? So first one, what force acting to the satellite? Okay, the force here should be the centripetal force. Centripetal force. Okay, centripetal force acting to the satellite. Okay, now they ask you what is the value? This force is what value? Okay, this force, the value, okay, just now we find it, the force is how many? Gravity is how many? Gravity, just now we find it as 9.26. Is it? ms negative 1 negative 2. So from here, they need to find out the satellite at the certain orbit. What is the value? So remember, F equal mg. We cannot using the centripetal force. There's a mv squared over r, because we don't know what is the v. So we're just using this formula. So the mass of the satellite is 100, is it? So we refer the question. Satellite mass, okay, 100 kg. So we take the mass of the satellite is 100 kg. Okay, then multiply with the gravity. There's a 9.26. So I get it, 926 Newton. Okay, we got 926 Newton force acting to the satellite when they orbit the Earth at the certain orbit. Okay, as not exactly become the 1000, because you are far a little bit. So what is the linear speed of the satellite? So linear speed of the satellite, remember the linear speed formula is if you got time, we can using v equal 2 pi r over t, but now we don't have the t. So we need to using another formula to find the speed. Okay, so we assume centripetal force is it. Okay, F equal mg just now, weight equal to the centripetal force, v square over r. Okay, now we need to find out is the v. So m we can cut it, that's not related with the mass. So from here you need to find the v square. So be the gr. G is the gravity of the satellite. R is the radius of the satellite. Okay, so from here you want to find the g, v, then you square root g r. Okay, the g just now we get it already, is it 926. Okay, what is the r? The r, there's a total, just now you find it, what is the radius satellite. So after that you can get the answer should be 7.85 times 10 power of 3 ms negative 1. Okay, so this one's the answer for the velocity, linear speed of the satellite. Okay, now we go through to the following. Okay, a spacecraft. Okay, spacecraft means they want to find escape velocity. Okay, so escape velocity we just using v equals square root 2 gm over the r. Okay, so from here they give you all the things ready, is it? So we just apply lah. Okay, g, the mass of the earth, then the radius of the earth. So we get it, the answer should be, okay, r you need to do first because they got height is a 1600 kilometer. Then after that you need to plus. Okay, this one is earth, spacecraft is here. Okay, the spacecraft distance 1600 kilometer. So you need to plus about the radius. Final answer should be 9.998 times 10 power of 3 ms 31. Okay, so this one is a number 8 answer. Okay, I show you the number 7C first. Okay, this one is a C answer. That means the force acting to the satellite. You write there's a centripetal force. Then the centripetal force actually the same like the weight. There's a mg. So m is 100. So g we find it the gravity for the satellite now. There's a 9.26. So I get it 926 Newton. Then we go to the B, okay, C, D, 7D. Okay, the answer is what's the linear speed? So we create again the formula. Centripetal equal to the mg. Then after that the V equals square root gr. So the r is just now the r. There is a satellite and also the earth. You need to plus total r is how many? Then you go to square root, then you get the answer 7.85 times 10 power of 3. Then we go, that is the number 8. Okay, number 8, this question we just apply only. Important, you need to set up this r. You need to plus the r first. Then after that we can join about the total all the thing. Then there's 9.98 times 10 power of 3 ms negative 1. Okay, so we finish the question number 8. Now we go is number 9. Okay, number 9 is a page number 3. Okay, number 3, the figure they show you there is the Saturn with rings made up with the small particle around it. The planet Saturn has the mass, okay, they give you the mass of the Saturn and the radius. Okay, first one, calculate the escape velocity of the planet of the Saturn. So V equal square root 2 gm over the r. So from here you can straightforward, you get the answer 3.55 times 10 power of 4 ms negative 1. So this was the answer for the escape velocity of Saturn. Okay, discuss the probability the small particle in the rings of the planet Saturn escaping in the outer space. This one is the maximum. So you want to escape to the outer space, your velocity must be enough from this value. So from here they ask you probability for small particle in the ring of the planet, they will escape or not. The answer should be no. That's impossible because your velocity too small. Small particle in the ring, then you just move unless you are over this velocity. This velocity already big enough. So your answer is, it is impossible. For those small particle to escape because the escape velocity of the planet is very high. Okay, you are high enough, so that means the particle, they just want to move, they also cannot escape, go to space. Okay, now we go to question 10. They got 3 bodies A, B, C, given that the gravitational force between A, B is P. Okay, this one, the gravitational force, there's a P. So from here they want you to find out the gravitational for BC and AC, but you state in the term of the P. So from here, first part AC, there's a P. BC, can you see BC? This one become 200 already. And become 200, that means we got affected for the gravitational force because the mass increase. So the first part, we need to find out what is the gravitational force for AB first. So G equal, this one for AB, force, gravitational force are not gravity. So we write about the force F AB. There's a G. Okay, small m and big M. Small m means 100. Another m also 100. Okay, distance. Distance is a 5. 5 need to square. So you get the answer should be 400. I get the answer 400. G lah. G, you don't have to change anything, it's okay. So we also can write there's a P because the question says there's a P. Okay, now I need to find is a BC and also AC. So you just using the same formula, you find it, what's the answer? Then your answer in terms of the P. So I get it is BC, there's a 2P. AC, the answer should be half P. So you need to write your answer calculation first. Then this one is the answer. Then later you do check, is it correct or not? Okay, this one is a question number 10. Okay, now we're going to see question 11. Table, they show the information for the 3 types of the orbits. There's a X, Y, and Z satellite orbiting the Earth. Okay, let's see the shape. We got ellipse, we got circle, and the height. Everyone is a difference. Okay, orbit period also different. Now they just want to find out to launch to 2 satellites P and Q to orbit the Earth. Satellite P must be, imagine the satellite, it can capture the image various locations. So another one is a Q. Q as a communication satellite. Okay, remember communication satellite normally we're using geostationary. Okay, Let's see the P. They want to imagine the satellite capture image various location. Various location, that means you can move. Okay, you can move. The time should be not same as the Earth. You also can move the orbit, also not exactly for the geographic for the orbits. You also can far away, you also can be closer. So this one must be non-geo. So from here we need to find out shape, height, and also orbital period. So we know the geo sure is a 24 hours. Okay, this one is either shorter or longer also can, but normally you want to capture must be shorter lah, because we can get it. Okay, the height normally we need to closer. Okay, closer. So closer, that means you can see very clear about every part. Okay, so from here they call you to determine which one orbit suitable for the P and also the Q. Then you need to explain your choice. So for this one question, they almost same like the essay question. So we need to write in table form also can. You can write in a point form. From here, the point form is more suitable because you want to explain the P and also explain the Q. So I show you the answer for the question number 9, 10, and 11. Okay, let's see the number 9. Okay, this was the number 9 answer. Okay, escape velocity, you do the calculation. The next one, they ask you the small particle can be escaped or not. Your answer is impossible lah, because the small particle to escape, because the escape velocity is too high. Okay, now we go to the question number 10. Okay, 10 we need to find out the gravitational force for AB, BC, and AC. So we find it, the first one is 400 G. So another one is 800. 800 means you got 2P. Okay, 200 G means you got half of the P. Half of the gravitational force from the AB. Okay, another one is 2 times bigger than the AB. Okay, last we can see question 11. Okay, let's see the A. Okay, I make it bigger, then you can see clear. Okay, let's see the first one. Satellite P is a imaging satellite. Okay, with following figures. Let's see the figures. Okay, orbital height is small, so that can clear. This one is aspect. Orbital must be smaller, so that can be clear photograph and can be taken the surface of the Earth. So that means the height, okay, must be less. Next one, the orbital period must less than 24 hours. Cannot exactly 24 hours. If exactly 24 hours, that means the Earth rotate, you also rotate. That means you cannot capture already. So that can be orbit the Earth several times. So many times they can orbit. Then the satellite will be different location above the surface of the Earth and can take the photograph in many different spaces. So from here, this one is orbital time. Okay, this one is the explanation. Why you must less than 24? First, you want faster. Okay, number 2, you can go to different location above the surface. Then you can take the photograph in many different places. Okay, number 3 is a shape. You want the ellipse. Ellipse shape of the orbit. So near and far. Okay, remember the ellipse. So that means you, when you go here, you are closer. Okay, another one. When you go another part, it becomes longer. Okay, remember the micro and the macro. Okay, so from here you can take the near and far photograph can be taken. Therefore, the satellite P need to be placed at the orbit X. Finally, the P will choose orbit X. Okay, so this one is the first one, explanation for the P. Okay, so this one is the answer. Then we need to go is the last one, that is the Q. Okay, the orbit for the Q. Which one we need to choose? Okay, now information in the table they want to show is Q is a communication satellite. Communication, I told you there's a geostationary. First one, the time must be orbit 24 hours. Reason, rotate together with the Earth and maintain the same location above the surface of the Earth. So this satellite can be received and transmit the communication signal then to the station of the Earth. So that means the rotation must be the same. So the signal is until where you also can go until which one location. Next one, circle. Circle means left, right should be the same. Circle of the shape. So the height from the surface of the Earth is constant. We do want bigger or smaller, higher and lower. So I want the height should be the constant. So finally I choose there's a cube. Okay, the height constant, the height become constant, then the circle shape. So from here the cube I want to choose is a orbit Y, 24 hours. So from here we finish our explanation for the Q and also the P. Okay, so we explain about the P for the shape, for the height and also the orbit. Remember the height we don't mention how many. We just say you want higher or lower. Then the orbiter also same. Okay, you are 24 hours or you shorter than 24 hours. You don't mention 1.41 or 41.33. Don't mention the number. Okay, so that's all. That one is a essay question for the 3.3 man-made satellite. So our lesson is until here already. So we finish the chapter 3. The coming soon should be the chapter 4. So for the student so hopefully you understand about these all tutorial question. Okay, so our lesson is until here. So the coming soon I will upload the chapter 4. There's a heat. Then the school also will resolve for you all the whole year of the module. So from here I don't know when they will call you go and take lah. So from here I also will upload. So the coming soon I will also do about the YouTube for the heat topics. So hopefully you enjoy about this lesson. Thank you everyone. Okay, one day live live 要关了。
关了啊，回去那个。
哇，
很好，很轻。